Today's lesson 1.9 is factor strings and prime factorization, and we're going to learn how to do these factor trees, which is also called prime factorization. We're going to talk about name collection boxes first, different ways to make 16. So there's a couple examples here. 8 plus 8 is 16, 4 times 4 is 16. See what other ones you can think of. Pause the video if you need to. Here's some name collection boxes for 12. 11 plus 1, 13 minus 1, 6 plus 6. There's Roman numerals. There's a dozen eggs. So that's kind of an example of an answer for 12. Hope you thought of lots of answers for 16. Ooh, 24. See how many answers you can come up with for 24. Other ways to name 24. Add, subtract, multiply, divide. Again, pause if you need to. There's lots of answers. Here's one answer, a factor string. Did anyone use a factor string? That's what we're going to learn about today. So the factor string for 24 is 2 times 2 times 2 times 3. 2 times 2 is 4, times 2 is 8, times 3 is 24. And we're going to learn how to make factor strings. It's a written string of numbers that multiply together to become 24. I will demonstrate how to do a vector tree for 24. This is a factor tree. I always like to think of it as the branches upside down, or a V, but we're going to separate the things that go into 24. So if we're going to think of two factors of 24. It doesn't matter which ones we start with. And then we look at those to see if either of those are prime. And 3 is prime. Nothing goes into it except itself. So I circle the prime one. 8 is not prime. I always say, is it done yet? Nope, something can go into it. So this is like, if you looked at it upside down, that'd be a tree branch that dumps into 8. So what times something else gives you 8? 2 and 4. This one doesn't get a branch because it's done already. It's prime. And you don't count the ones unless it's a prime number. Now I'm looking at these to see if either are prime. Yes, 2 is prime. It's done, so I circle it. But 4 has something to go into it. It's a composite. So we're going to split 4. 2 times 2 is 4. I usually don't write the times in there. I just think that has those going together, and both of those are prime. So our factor string is the string of numbers we circled. It's the string of numbers that are prime that go into 24. Put them in order. So the 2 is the smallest. 2. Got this one. Times 2 times 2 times 3. The easier way to write that, and I always call it the fancy way, is with exponents. How many 2's are there? So we've got a 2, and we have 1, 2, 3 of them. So 2 to the third power times 3. We just have 1, 3. So this would be a factor string answer. This would also be a way to put a factor string answer. So this factor string on the top has 1, 2, 3, 4 products. Or 4 factors, I should say. The product's the answer. So either one of these would be an okay answer. That's a factor tree. Let's do another factor tree. Let me get my eraser. Wish that worked. like it does on the board. So we're gonna get the pen. We're gonna do a factor tree for the, before I show that, I wanted to show you that it doesn't matter how we start. We get the same answer depending on which things we start with. Let me show you that for 100. So here's 100. What times what is 100? I'm going to do 2 times 50. Circle the ones that are prime. So 2 is done, it's prime. 50 has things that go into it, so split it. Ooh, I'm going to do 2 again. 2 times 25. Circle the 2 because it's prime and done. 25 has stuff that goes into it, so we're going to split it. 5 times 5. And then we're going to write our factor string. 2 times 2 times 5 times 5. If I tried that, I should get 100. 2 times 2 is 4. 4 times 5 is 20. 20 times 5 is 100, yes. And write it with exponents. 2 2's and 2 5's. We have to write this number first, the big number, and then we write how many times. So either one of these would be the correct answer. This one's factor string, and this one's with exponents. If I did 100 another way, let's see if I can squeeze it up here. If I did 4 times 25, ooh, this time neither one of them is prime, so I gotta split that one, gotta split that one. 2 times 2 is 4. 5 times 5 is 25. So even though I started with different factors, I still get the same answer. Let me do one more. Excuse me. Erase. Let's do 36. My favorite number. What goes into 36? Several things, but I'm going to do 6 and 6. Are either of those prime? No. So they both need split. 2 times 3 for both of them. Those are all prime. My factor string is or there's 2 2's and there's 2 3's. Notice this isn't 3 times 2. This is 3 squared. 3 times 2 would be 6, but this is 3 times 3 is 9. So either this one is okay for a factor string, and there'd be 1, 2, 3, 4 factors, or this one is okay with exponents. Alright, we're going to do factor strings for 30, and we have some blanks here. Remember that the star means the same as multiplication. In order to get our factor strings, we're going to do prime factorization, which is what we were working on, factor tree. So whenever you need to do prime factorization, it's the same thing as saying do a factor tree. So we're going to split 30. Let's do 3 times 10. Remember, we can do different ones. Prime factorization, 3 is prime. 10 is not done. It can be split yet because it's composite. 2 times 5, and those are all prime. So my factor string is 2, I'm doing them in order, times 3 times 5. They're saying for 54, we're going to do prime factorization. So what goes into 54? Well, I know 2 does, because according to my divisibility rules, 2 If it ends in an even number, 2 will go into it. Ooh, what's half? 2 would be half of 54. Well, half of 50 is 25, and half of 4 is 2, so 27. So 2 is prime, but we have to split 27. 3 times 9. 3 is prime. 9 is not prime yet. Something goes into it. So this time I need the bottom one. 2 times 3 times 3 times 3. Or I could write 2 times 3 to the third power. There are 3 3's. And I did some of these examples. You try 50. Try 72. Here's the directions from your book about factor trees and exponents. Here's an example of factor strings where several things can go in 20. It's like the name collection box, and seeing how long they are. The prime one's always the longest one because it's split into the most pieces. Page 26, for the top part you're going to do factor trees, and then you can use your slate or paper and write your answer on this paper. So for example, 27 is 3 times 9. 9 needs split. 3 times 3 is 9. So the answer would either be 3 times 3 times 3, or if you want to write it the shorter way, your answer would be 3 to the third power, 3 3's. Work on Journal 26, Part 1. Then there's examples talking about exponents on the bottom of that. The exponent's the little baby number that's up at top that tells how many times to multiply the base or the big number. On Journal 26 continued, there's a couple examples here. So the first example is 2 to the third power. So you write 2 3 times, and you would get 8. You would not get 6 because that's 2 times 3. This is 2 to the third power. 2 times 2 is 4 times 2 is 8. The next example is 2 squared, 2 to the second power, times 9. 2 times 2 is 4. 4 times 9 is 36. So on A, take your number and write it out like the example and write your answer. On the bottom, it's having you practice writing the powers. Here's an extra game. And here are math boxes. Here's the study link if it's assigned to you. And here's just some extra things that you can do if you just want something extra to do. It will not be collected. This is just kind of an extra interesting puzzle too.